We know oxygen concentrations in normal atmosphere air range about 21%, depending on where you're at. If you're at ground level or sea level, you have high concentrations of oxygen, around 21–22% of oxygen in the air. We know that when we engage into fire and fire starts to consume oxygen, those levels drop. We know that combustion is sustainable at very low levels of oxygen in the air, but that combustion is not necessarily as powerful or as free burning. So when we look at buildings, we look at compartments, okay? A building that's closed up becomes a compartment. If it's sealed up very well, then there's a limited amount of oxygen in that room. For example, the only amount of oxygen you have is what's in that room. As a fire starts to consume that oxygen, okay, because it needs the oxygen as part of the combustion process, as it consumes that oxygen, it reduces the level of oxygen in the room. Well, we know that we need a minimum of 16% oxygen to sustain ourselves. When we start going below that, we get into hypoxia, we get into negative effects of the lack of oxygen. So then we can pass out, we can become disabilitated, we can become disoriented from the lack of oxygen and not be able to make an escape. So we start getting to levels below 16%, that's when we start having problems. When we get a little bit lower than that, then we start to have more significant issues. As the oxygen is depleted in that compartment, now the fire itself, just like we become affected due to the lack of oxygen, the fire is going to become affected. It's not going to be burning to the extent or intensity it was before, so the temperature is going to drop. But the amount of burning material is still going to be there. The fuel is still going to be in a large quantity. You're still going to have high temperatures, not necessarily as high as it was when it was free burning, but you're still going to have high temperature. We used to talk about this in the beginning as you had fire was free burning, you know, incipient, free burning, and then it went to the decay stage, or basically the smoldering stage. What we're talking about now is all of the oxygen being consumed and the fire is now going into a smoldering stage. Well, what does it need? Well, we talk about the events that occur, the backdraft. This is when if oxygen is introduced into this environment, everything that's burning in there just needs one thing to be able to continue burning, and that's oxygen. It has fuel, it has sufficient heat, and all it needs is that oxygen, and that's where you have that rapid oxidation, that explosive type of event. We'll talk about that a lot in tactics, but I want you to focus on those different types of events. When we have a fire that starts off and it's free burning and it starts heating, as we said earlier, the fuel starts to heat. The more fuel it heats, it becomes almost exponential. But when it gets to a certain point, then you have what you call a flashover. A flashover occurs generally at the chance when you go from incipient to free burning. That's about when that occurs. The incipient fire has now developed enough heat to cause significant off-gassing or pyrolysis of all of the gases and solids in the particular compartment. Gets past that point, now you have almost instantaneous fire everywhere because everything has reached its flame point or its flash point, and it now is giving off enough vapors to sustain a continuous flame. That's really basically when your flashover occurs. Your backdraft is on the backside. When your backdraft occurs, it's because the oxygen in the area has been depleted. The compartment is enclosed, the oxygen's been depleted, and now you're introducing fresh oxygen into an already heated and charged environment. You're giving it that extra oxygen, and the rapid oxidation occurs because of that. So flashover is a heat-driven event, backdraft is an oxygen-driven event. So the two differ in those aspects. This is going to be important when you get into tactics because this happens to be one of the discussions that we have in our tactics, is describe those two events and how they differ from one another. Now a smoke explosion is different. A smoke explosion oftentimes is confused with a backdraft, but a smoke explosion really is not. We know that carbon monoxide will explode or rapidly, violently ignite at certain temperatures. Gets up to 1200 degrees, there's a potential that it can explode or ignite. Basically, smoke is made of particulates. Particulates are solids, solid gases that are vaporized. Those vaporized solid gases and particulates are still flammable. So when certain smoke engages, it becomes a fuel mixture, almost like when you have gasoline. If there's too much gasoline in the air, you can light a match, it's not going to do anything because it's too rich. If there's too little gasoline vapors in the air and you can light a match, it's not going to do anything because there's too little. Well, smoke is the same way. If you have too much smoke, then there's too rich an environment, then it won't explode. But if you have too little smoke, then there's not enough smoke in the air and it's not explosive, then particulates won't ignite. But if you get to that right mixture, where you have just the right amount of smoke, right amount of particulate, enough oxygen, and an open flame, this is when you can have that explosion. So a smoke explosion can occur pretty much at any time, usually when there's incomplete combustion in a compartment, and the materials or products in that combustion are of an ability to catch fire. Carbon dioxide, carbon monoxide, all of the different things that make up that smoke. Acrylenes, the vapors, the benzenes, all of those things that are in that smoke have the potential to rapid oxidate as well, and that's when you have a smoke explosion. So if you look at a backdraft is an oxygen-driven event, a flashover, a heat-driven event, and a smoke explosion essentially is a fuel-driven event. It's driven by the amount of fuel in the smoke and the volatility of that smoke. So that's basically those three events explained in a simple way.